In this video, I'm going to share 5 advanced tips you can use in Claude for your finance work that will instantly take your outputs from beginner to advanced. If you're using Claude for Finance and your outputs still feel generic, inconsistent, or not something you would confidently show in an FP&A review, then this is exactly for you. Now, some of you might be thinking Claude just isn't reliable enough of real finance work, but that's not the issue. Claude isn't the problem. Unstructured usage is the problem. When people say AI is inconsistent, what they usually mean is that they're prompting without control layers, without verification loops, or without workflow boundaries. And in finance, that's completely unacceptable. These 5 stages are not shortcuts. They're structural controls that are designed for environments where numbers are audited, assumptions are challenged, and outputs must hold up under audit. So today, I'm going to walk you through a structured Claude framework that moves you from unstructured prompts and fragile outputs to controlled, auditable, boardroom-ready financial workflows that actually survive the real FP&A world. If you want all the prompts, all the frameworks, and all the implementation templates I'll use, you can join my free community using the link in the description below. Tip 1, find every hidden trap in your spreadsheet in 60 seconds. Okay, so for the first tip, I'm going to explain to you why it's important to find every hidden constant in your spreadsheet before making any modeling decisions, because if numeric literals are buried inside formulas, your scenario analysis is not truly controlled. This step ensures every assumption is visible, centralized, and auditable. In real finance work, models don't fail because Excel can't do the maths. They fail because someone casually typed 0.2 into a formula. They threw a plus 5,000 into an operating line just for now, or they copied 1.2 across a few sheets without explaining what it was for or documenting it. Now, these numbers don't break the model immediately, which is why you don't notice them right away. But totals still calculate and they will ruin the output. This is why when a reviewer asks where an assumption comes from, there is no clear answer. Most teams discover these issues only after the model has already been used, when fixing them requires manual tracing and credibility is already at risk. This is precisely why we need to scan formulas directly for hard-coded numeric constants instead of relying on visual review. And the way to do this is a structured, controlled way. We want Claude to scan the P&L sheet for formulas containing numeric literals, then create a new sheet called constants underscore audit and log each occurrence with cell address, original formula, detected constant, suggested named assumption, and a fixed formula referencing the assumptions sheet. It must also summarize the total constants found and identify the top 3 most reused constants. Nothing is replaced at this stage. Now, here's how we do this. For the first step, you need to save a backup of the workbook before any replacement so that changes are reversible. The second step is to open the workbook in Claude's Excel add-in and run the scan prompt exactly as shown here, instructing it to analyze formula text and generate the structured constants underscore audit output. The third step is reviewing the output to verify that constants underscore audit exists, that each occurrence has the correct cell address, that assumption names follow conventions, and that the summary reports total constant and top 3 values. Now, most people manually check formulas. They run limited find or replace, or they create ad hoc cells leading to missed occurrences, inconsistent naming, and no audit trail. So this is where it usually goes wrong. Separating scan, review, and replace maintains control and ensures replacements are mechanical and traceable. Only after review do you run the replacement prompt to update the original sheet. After replacement, confirm that the P&L formulas reference assumption cells instead of hard-coded numeric literals. Verify that the assumption sheet contains the new named assumptions and values. And recalculate sample outputs to ensure no reference or value errors appear. And perform a quick model level check. Log what was changed so that you can compare later on. While this tip is solid, there is always a risk of false positives, especially in row indices, version numbers, or technical constants that may be flagged as such. Large sheets may take longer to scan as well. Locale formatting may affect decimal detection. Now this is where you stay vigilant. Not every constant needs to be replaced, so make sure you check everything. If you execute it properly, you will see the P&L sheet with constants along with a structured constants underscore audit sheet listing each occurrence, a summary of repetition patterns, and after approval, formulas updated to reference assumptions. Anything less means the cleanup is incomplete. Once you've checked everything, we can now move on to tip number 2. Tip 2, Claude knows which customers are about to burn you. Okay, so in this tip, I'm going to explain why it's important to identify customer credit and attrition risk directly from your transaction ledger. If refund behavior, payment status, and purchase gaps stay buried in rows of data, collection risks build quietly. So this step ensures risky customers are surfaced early before surprise write-offs or working capital strain appears. In real finance work, risk doesn't show up in a single metric. It shows up in patterns such as rising refunds, longer purchase gaps, and declining average ticket size. Finance teams often analyze AR aging and churn separately, but they rarely process these transactional signals into a single auditable model-ready score. The problem is not one refund. It is refunds combined with shrinking frequency and small revenue contribution. So these signals on their own aren't noticeable, which is why they go unnoticed until someone points them out. This is precisely why we aggregate transaction data at the customer level and score risk structurally, instead of relying on intuition or isolated dashboards. We basically want Claude to analyze the transaction sheet and calculate for each customer the total transactions, the percentage with payment underscore status equal to refunded, the average revenue per transaction, the average gap between purchases, and an overall risk score on a 1 to 5 scale. The output must be a new sheet called customer underscore risk underscore analysis, sorted by risk descending, so the highest risk customers appear first. Nothing is acted on at this stage. Now here's how we do this. The first step is to open the workbook in Claude's Excel add-in and run the primary prompt exactly as written, structuring it to aggregate from the transaction sheet and produce the structured customer underscore risk underscore analysis table. When the prompt runs correctly, you should see the transaction sheet with rows of customer ID, dates, amounts, and payment status, and a new sheet, customer underscore risk underscore analysis, with columns customer ID, total transactions, refund PCT, average revenue, average gap days, and risk score, sorted in descending order. A short summary should indicate the total number of customers analyzed, the number flagged as high risk, scores 4 to 5, and the top 3 risk drivers observed. Before trusting the scores, confirm that customer underscore risk underscore analysis exists with the expected columns, that sorting is correct with the highest risk at the top, and that the distribution of score looks reasonable, not all 4 to 5 or all 1 to 2. Select a flagged customer and check the transaction rows to verify counts, the refund percentage, and the average gap logic. Manually compute refund percentage for at least one customer and confirm that average gaps are calculated using sorted transaction dates, not calendar buckets. Make sure there are no missing dates or null amounts that would invalidate averages. Most teams export transactions into BI tools. They eyeball a few problem accounts, or they rely on sales and customer success flags And this is wrong because this approach is very manual, it's inconsistent and it's reactive. But by forcing structured aggregation and a composite score, you create an auditable, model-ready risk layer that can be linked back to raw transactions for verification. But there are limits here, and this tip will fail if you have missing or incorrect dates because they make the average gap meaningless. Refund semantics may overstate issues if partial refunds or credit notes are common, and certain business models such as marketplaces or subscriptions and milestones billings can create patterns that appear risky but are common in real life. Customers with only 1 or 2 transactions can produce extreme scores, and revenue units must be normalized. This is why you do not automatically act on raw scores for strategic customers without manual review. But when executed correctly, the highest risk customers are immediately visible, backed by traceable metrics, and ready for the next steps. Now we can move on to tip number 3. Tip 3, your revenue's secret calendar revealed. Let's talk about this next one. I'm going to explain to you why it's important to uncover your revenue's hidden calendar before making forecasting or budgeting decisions. Because if seasonality is not quantified properly, your projections will be mistimed. So this step helps you understand better when the business naturally peaks and dips using normalized, defensible comparison. In real world finance, revenue seasonality rarely shows in raw monthly totals. Teams focus on year over year or recent months, but often don't compare January to January or March to March across years. Now, without normalization, seasonality just stays hidden, leading to poorly timed promotions or misleading performance comparisons, and perhaps inaccurate forecasts that assume steady growth. This often goes unnoticed until someone points it out at the last second. But this is precisely why we compare like-for-like calendar months across years, and we anchor results to a global average instead of relying on intuition or manual pivots. We want Claude to use the monthly revenue sheet, and for each month from January to December, calculate the average revenue across past years. Compare it to the global average expressed as a percentage of over or under. Highlight the top 2 peak months and bottom 2 weak months, and then output a seasonality profile table along with a short memo summary suitable for the CFO. Now here's how we do this. The first step is to open the workbook in Claude's Excel add-in and run the prompt exactly as written against the monthly revenue sheet, instructing it to calculate month-level averages across years, to compute percentage variances versus the global average, to identify the top 2 peaks and bottom 2 troughs, and generate both the structured seasonality profile table and the short memo. Now, when the prompt runs correctly, you should see the monthly revenue sheet loaded and a new seasonality profile table with columns such as average revenue, percentage versus global average, and rank. The top 2 peak months and the bottom 2 weak months should be clearly labeled. A short memo should summarize the findings in plain language with percentages that match the table. Now, before trusting the output, confirm that all 12 months are included, that the global average is calculated from the same data set and period, and that at least 1 month's average ties back to the raw data when spot checked. Also, check whether all the peaks and troughs align with the percentage ranking and whether the memo figures match the table exactly. Now, most people build manual pivot tables, they eyeball charts, or they rely on gut feel about busy seasons. Often, this is influenced by recent performance. By enforcing month-to-month normalization and anchoring to a global average, you remove spreadsheet bias and you produce both numbers and narrative in a format that is defensible. But don't forget, limits exist. Under 2 years of data, then seasonality is unreliable. Changes like pricing or channel expansion or M&A or revenue timing can distort comparisons. Large deals, partial year data, and mixed shifts can also mislead. Now, seasonality guides decisions on promotions, inventory, staffing, and guidance, but it doesn't make decisions automatically. When executed correctly, your revenue's hidden calendar becomes more visible, more quantified, and ready for strategic interpretation. Now we can move on to tip number 4. Tip 4, Claude turns Excel into a storytelling machine. Now in this tip, I want to share why it's so important to turn raw revenue data into a clear visual story. Disconnected charts without a narrative rarely prompt any action. So this step helps you create visuals that are aligned, styled consistently, and equipped with captions that are directly linked to the data. In real finance work, teams often create isolated charts such as a revenue line or a refund bar without connecting them or explaining their meaning. Executives, they want a quick visual summary that links numbers to actions, and achieving this requires more than just charting. It needs clean data, it needs consistent labels, it needs aligned tables and captions from the same data source. And most people stop after one chart and then they add manual commentary, resulting in weak outputs that quickly become quite dated. So that's why we start with data hygiene and then create 3 linked tables that support 3 side-by-side charts with captions. Now here's how we do this. First, you need to run the prompt exactly as written in the Claude Excel sidebar. It cleans and it verifies the transaction sheet, extracts the month label as plain text, a month and 4 digits for year. It removes formatting inconsistencies, it merges cells, removes blank and hidden rows, and then re-audits before proceeding. Then for the next step, it creates a new sheet called revenue_storyboard and builds 3 data tables. Monthly revenue trend, product mix by month, so basic, pro, and enterprise, and monthly refund rate percentage. And then it generates 3 side-by-side charts, a line chart for revenue, a stacked area chart for product mix, and a clustered bar chart for refund rate using the specified color scheme. Finally, it adds key insight captions under each chart, applies styling such as white background, Calibri, grid lines off, and includes a title, subtitle, and legend, and ensures the storyboard is fully visible and data bound. Before trusting it, verify that month label is plain text and sorted. Each table covers the same month ranges, charts reference table ranges which are not pasted images, color mapping matches the spec, captions match table values, and that there are no reference errors or hidden values. When executed correctly, the result is a clean, synchronized storyboard. Now we can move on to the final tip of the day. Tip 5, Claude just built me a shareable forecast dashboard in HTML. Okay, so in this tip, I'm going to explain to you why converting a spreadsheet forecast into a single portable HTML dashboard matters. This is because static exports slow down distribution and create unnecessary friction. So this step ensures that stakeholders can interact with forecast assumptions directly in a browser while remaining aligned to spreadsheet logic. In real finance work, forecasts live in spreadsheets, but sharing interactive views typically requires BI tools or developer stacks. Most teams export PNG charts or they build permission-gated dashboards that become a bit too boring. So the non-obvious solution is a single HTML file with existing data and explicit forecasting logic, but only if parity with the spreadsheet is verified. Now, this is precisely why we require Claude to provide the forecast from monthly_revenue and its assumptions, apply linear monthly compounding, and then embed both the data and the logic in a single dependency-free HTML file. Now here's how we do this. First, you run the main prompt exactly as shown. Claude needs to forecast the next 36 months using price unit_growth_annual and unit_growth_annual. And then it needs to create an interactive chart with actual navy and forecast teal. It also needs to add sliders for price and unit growth, a forecast horizon drop down with 12, 24, 36 and 60 months, scenario buttons like base, aggressive and conservative, and finally we need a theme toggle and a data table toggle, all with a single HTML layout. Then request the complete downloadable HTML source and a verification checklist that maps the first 3 forecast months to specific spreadsheet cells. Before distributing, confirm forecast parity by spot checking in the first 3 months against the spreadsheet and test interactivity such as sliders, drop-down buttons and toggles. Then verify color mapping and labels. Open the file offline to avoid network calls. Check responsiveness. Confirm there's no sensitive data in the file such as confidential client information, and ensure the file size is reasonable. When executed correctly, you should have a portable interactive forecast dashboard that remains auditable and directly tied to the underlying model assumptions. And that's it. You now know 5 advanced tips using Claude that feel illegal, but they get the job done. If you want all the prompts I used, you can join my free community using the link in the description below. Let me know what you think in the comments. Thank you very much for watching, and I'll see you next time.